Hey guys, so in this video here, I'm going to show you guys two examples, application of sampling distribution and sample means, or the two result that we can apply from the central theorem. That will be, in the previous video, we've seen these two results already. I'm going to go ahead and just kind of restate that in here. So if we have a distribution of x bar, which is sample means, and as the sample size is large enough, or when n is greater than 3, some book would say n is greater than 30, sorry, or I would say just as n sample size increases, this distribution x bar here will be approximately normal, approximately normal or bell shape. And then we have these two results. We have the means of all the sample means, or the means of the distribution of x bar is going to equal to the population means. And then we have the sigma x bar, or the standard deviation of sample means, is going to be the original population standard deviation divided by the square root of the sample size n. So we're going to look at example where we use this in a problem. The first example I have here is an elevator question. So it says that when designing elevators, an obvious important consideration is the weight of capacity. And it says that Ohio college student died when he tried to escape from a dormitory elevator that was overloaded with 24 passengers. The elevator was rated for a capacity of 16 passengers with a total weight of 2,500 pounds. Now, if you next time you ride an elevator, it should say somewhere inside the elevator maximum capacity and for how many passengers or how many people are allowed in an elevator. So what this problem is saying that, you know, some sort of data is given. So this is the data set here, and this could be the recent data, could be 10 years ago. I don't know when this data was collected. We're given that the distribution of the weights of adult males versus females, and we're also given that the distribution of those two data set are normal. So using the probability of one person selected to figure out what would be the chance of a group of people has the average mean exceeds certain weight. And this saying that an elevator loaded its capacity of 2,500. So if an elevator has a capacity of 2,500 with 16 possible males, the average weight of a passenger should be around 156.25 pounds. So if one person weighed 156.25 pounds, then 16 of them together reach the maximum capacity. So the part A we try and find is what would be the chance using the data from all the adult males' weight, using this distribution there, what will be the chance a random selected adult male has a weight that exceeds this 156.25 pounds. If the probability is high, chances that a group of 16 adult males will certainly exceed the loading capacity of this elevator. And so that's what we're trying to get. So what I'm going to do is I'm going to go ahead and say distribution of x, okay? X is where x is the random variable of, you know, weights of adult males, right? Adult males. Okay, so that's going to be our first distribution, and we're given that distribution is normal with the mean of 182.5 pounds and sigma is 40.8 pounds. Okay, so that's what we're given there. Okay, so we asked to find the probability that a random selected adult, so a random selected adult from the population, adult male, has a weight exceed or greater than 156.25 pounds. Okay, so what would be a chance that a random adult male person is weight more than 156.25 pounds? So that is the same thing as asking what is the probability that x exceed 156.25 pounds. Now, in the previous lesson, I showed us how to do this using the z-score table to look up the area or the probability. So I can demonstrate that in this picture here. So 156.25 is below the mean. And then we're trying to calculate this area there, okay? So certainly we can do this a long way, convert this particular value of x to the number of standard deviation below the mean, which is the z-score. Use this z-score table, look up the area to the left, subtract from the 1, and we'll get the answer. But that's in the previous lesson. In this lesson, we're going to use the TIA 384 command to get the answer of this. So we're going to use a normal CDF command, and that's gonna be lower, upper, mean, and standard deviations. Okay, so that's the command on the calculator. Will bypass the long method and allow us to get the answer really quick. So now that's gonna be equal to normal CDF. The lower bound for this, so it's kind of weird. The lower bound for this is actually, in this case, not going to be hard, but the upper bound is going to be weird. So this is going to be the lower bound, right? We're looking at the lower bound for the area, so it's going to be 156.25. The upper bound is when the graph crosses the horizontal axis where the graph itself, the density curve, which is 0. We don't know where that would be. So to be safe, we're going to go with 9,099. Okay, so whatever that might be, we don't know when. The mean for this distribution, the mean is 182.9 pounds. The standard deviation is 40.8 pounds. And if we type this in TIA 384, it should give us an answer, or give it that area or that probability of a random selected adult males has a weight exceed 156.25 pounds. So I'm gonna go ahead and go to my calculator app here. I was able to find an app that works with this iPad. It may not be similar as your calculator, but it has the normal CDF command. So I'm gonna go ahead and go do second distribution. So that will bring up all the distribution, and we'll do normal CDF. The lower bound was 156.25. The upper bound was 9,099, whatever that might be. The graph crosses the x-axis. Comma, the mean is 182. What was that? 182.9. 0.9, and then the standard deviation is 40.8, I believe. Yep, 40.8. So that will give us what? 74%. So we're gonna say 0.7431. So we're gonna say that's 0.7432. Let's round that up. So this saying that if a random selected adult male will have a chance of almost 75% that will weigh more than 156.25 pounds. Okay, so that's what this answer is saying. So we say that this answer means the chance of a random selected adult male will have around 74% chance. Will have 74% chance of weight more than 156.25. I think I worded that really weird there. So that's pretty high. You go on the street, you pick the random, you go up to a random adult male and ask what that person weight would be. That person has a 74% chance being weight more than 156.25 pounds. And I think you should do the same thing here. You can do this on your own. Go ahead and calculate what would be for, instead of male, trying females. Okay, so do that on your own and see what will be the answer for that. All right. So that's part A. So now in part B, this is where things kind of weird and confusing here. It's all in the wording actually. So knowing that there's a 74% chance of a random adult male will weigh more than 156.25 pounds, we want to know what will be the chance that any random a group of 16 people, adult males, walk into the elevator, what will be the chance that group of 16 people will have an average that exceed 156.25 pounds, meaning what is that probability that the elevator will be overload if a group of of 16 adult males walk into an elevator at the same time. Okay, so it's saying that what is the probability that a sample of 16 adult males has a mean weight greater than 156.25 pounds. So now I'm going to draw another distribution. I'm going to say this distribution here, distribution of X bar, where the sample size is 16. And because the original population is normal, this distribution will be normal as well. And the mean of all these sample means is the same thing as the population means. And that's the result from the central limit theorem. So this mean here is equal to that mean. And then the standard deviation of this distribution is sigma over square root of n. In this case, sigma is the original population standard deviation divided by the square of sample size, which is 16. And let's see what would that be. 40.8 divided by 4. So 10.2 will be the standard deviation for the distribution of sample means of all groups of 16 adult males. Okay, so this would be that distribution. So now we asked to find what would be a chance. What would be a chance that a sample of 16 adult males has an average that exceed 156.2 pounds. So we're looking at this area here. Okay, you probably wondering where this number 156.25 pounds come from. That's come from the fact that the elevator has a capacity of 2,500 pounds. Meaning, you know, if we look at it, 16 people in an elevator, that average out to a person should be weighed around 156.25 pounds. So the 16 here is just kind of an arbitrary number. We can choose 4 or whatever. It's also relatively related to what will be the weight distribution currently for United States as well. So that's all relatively, you know, random in a way where it depends what we working with. I'm thinking this data set here is kind of old. I don't think this is current. But anyway, let's get back to our problem here. So we're asked to find this area, and that area there is the same thing as the probability of X bar greater than 156.25 pound. Okay, what will be a chance? What will be the probability that a sample of 16 random selected adult males has an average weight that exceeds 156.25? Okay, that means if the probability is high, that means the elevator has a really good chance of being overload. So this notation stands for the probability, the probability of a sample of 16 with average weight more than 156.25. Okay, so we can do the long way, but in this video I'm going to show you guys the short way, and that is used in the normal CDF command. So very similar to part A, we're going to do normal CDF lower, upper, mean, and then standard deviation. Okay, the reason why I write down the whole thing like that, just to show you guys that, you know, it's important to know which distribution we're working with. What is the probability that we're trying to find? What is the area that we're trying to find with respect to certain distribution? In this case here, since we're trying to find out the area or the probability for a sample of group 16 to exceed certain value, so that means we are working with the distribution of X bar. So therefore, when we do this command, okay, the lower is still 156.25. The upper is still going to be 9,999, because again, we don't know where that's going to hit the horizontal x-axis. The mean is still going to be 182.9. The standard deviation is slightly different, because now the standard deviation for this sample means distribution is not 40.8, but it is 10.2. Okay, so that part is really important. A lot of students will forget that part. You know, forget to include this part here as the different part. That will determine which distribution we're working with in this case. So let's go ahead and type that in our calculator and see what we get as the answer here. So second verse, normal CDF, 156.25, comma 999, comma 182.9, comma 10.2, and that will give us 99% 0.55, so 0.9955. Okay, let's take a minute to discuss what this answer means. Okay, this saying that if the chance of one random selected adult has a weight more than 156.25 pounds is about 74%. That means we are likely to have a group of 16 adult males has an average weight exceed 156.25 pounds, meaning there's a really high chance that the elevator will be overloaded if we see a group of 16 adult males in an elevator. Now, if you like me, you know, I'm short, skinny, you know, it's you know, you walk to an elevator, you see a 16 people that look like me, chances are the elevator won't be overloaded. But if you know, if you go in there and you look at a group of 16 people that, you know, typical average American adult male, most likely the elevator will be overloaded if there's 16 or more adult males in there. So that's an example I want to go over. This is longer than 10 minutes as I wanted, or as I intended to make this video up. But you know, I want to make sure that the steps are clear, so I slow down quite a bit to just cover this one example here. So I'm gonna go ahead and pause the video here. In the next example, I'm gonna go over this one here. This is from the homework. This would be another application where we use the central limit theorem to solve the problem using distribution of sample means.